Okay, question 5. An aircraft starts from rest, so I know that velocity, I'll put a V rather than an S, equals 0 meters per second, accelerates along the runway for 36 seconds, and on takeoff, it's going to reach a final velocity. Let's put that as U because that's the initial velocity, U, and V equals 82. So we're going to need our A equals V minus U over T. Plug that in. So 82 is where it finished, 0 is where it started, divided by 36, and it says show the aircraft is about 2 meters per second squared with its acceleration. Well, we get an answer of 2.3. We write a little sentence saying, and this is approximately 2. Next part, calculate the distance. So that's going to be the X in here. The aircraft travels along the runway before. So we're going to rearrange this. So you can see that 2 in the A is going to go underneath. So we're left with X equals V squared minus U squared over 2A. And then we go and find all the values from above. Now, the main mistake made is students just forget to square the tops. So put that all together. We need 82 squared minus 0 squared. So that's 6724 divided by 2 lots of the acceleration that we worked out, 2.3. And that comes to 1461.7 meters. You'd have had a mark if you'd rounded that up to 1,500 meters. But I'm going to leave it as it is because it doesn't tell me what to put it as. Suggests one reason why the length of the runway is much longer than the calculated distance. So here we just got to say, well, things can go wrong. The weather can go wrong. We could have a really icy runway or something. Yeah, so anything to just say it's a backup. So we could have an unusual headwind, an engine failure, poor weather, a heavier plane, anything. Any sensible answer in there to just say that we need to be careful because some things can change. Next one. The aircraft lands with a velocity of 71 meters per second. The mass is 3.6 times 10 to the 5. Calculate the kinetic energy. So we're going to need our KE equals half mv squared. And we just got to remember to square that. Put that all together. We get 907,380,000. Or if I wanted to, I could have rounded up and done 9.1 times 10 to the 8. They'd give you the mark for this answer though. When the aircraft has come to a stop, all the kinetic energy, it's your favourite. How often has this come up? So we're going to use that beautiful word dissipated, and we've got to talk about thermal energy. So where's all that kinetic energy gone? It has been, there's air resistance which dissipates thermal energy into the air or into the environment. And that's that.